Hi there, Andrew Jackson, AJ Design Studio. I'm going to try modelling the main form of the Apple Watch, an older Apple Watch in Solidworks. So I've been putting this off for a while. I do have this model here of a Apple Watch, which I modelled a few years back in Rhino for some other reasons, and so I'm using this um, as a reference. I'm not going to make direct references, coincident or anything like that to any of this geometry. It's just there as a visual reference. I did spend a lot of time modeling this, so I know it's and analyzing it against the physical object, so I know it's fairly close. So yeah, it'd just be interesting to see, these corners here were made mainly by manipulating the CVs in Rhino versus a curve-based approach in SolidWorks. Okay, so I have done a little bit of setup already, so I'll just run through that. I've set up a sketch on in this case it comes through as the top plane, which just basically sets the main dimensions. And then I've set two planes up, the rear face and the front face, which happen to be the same dimension. And then I've also created like a delineated where the flat area is on the front and back face of the product. So those are offset off this first sketch I made. And this circle here is delineates where the extrude ends and it turns into the blend around the corner. Okay, and I have made, let's title this, I have created the main section for the extruded part of the form. So in this case I've used my reference, which is one of these, and the lens. And this is a high degree spline. It's a degree 8 spline, and it is G3 for this flat face on the front and flat face on the back, because I have 1, 2, 3, 4 CVs lined up linearly, and same on the top. It's a G3 connection, and then I have this point here floating around space, and I've also, because I want the product tangent or widest at the mid plane here, which is equidistant between the front and back, I've added a vertical line here and made that tangent to the spline, so that means it's going to be widest there. I do know, because I remember how I built the Rhino model, that I actually built a spline or a surface through here, through the fullest point, and then I terminated it here, and then created another surface through here. For this exercise, I'm just going to see if I can do it in one surface curving right from front to back, and it's fairly close, and the curvature is what it is. It's a bit peakier here, but that's fine because the lens does sort of sharpen up here, curvature. Okay, let's turn that off. I'll exit that sketch. I'm not going to bother dimensioning it, because it's not like it's a concept model or anything. It's not going to change. So what I've done is I've extruded a surface up to this point here, which is my first sketch, which is controlled by that circle, which is a circle with its center on this virtual sharp. Okay, and then I have added an axis through the front and right plane, which I've then made a copy of that extruded surface, rotated it 90 degrees, and then I'm going to move this extruded surface to line up with my construction geometry here, like that. So if you haven't used move copy before with constraints, coincident, basically I've got this corner here and then I want that to be coincident with that corner of that sketch. And then I've created a plane through this point here, which again is where the blend starts, and that plane goes there, you can see, and then that trims that extrude back. So that means whatever I change here, this updates and changes as well. Okay, so this is my starting point. So I'm going to create a planar surface on the rear face and on the front face. Let's do the front face first. So I'm going to sketch, and again, I remember from when I made this in Rhino, this is going to be a degree 7 spline between these 2 points. So 1, 2, 3, 4, 5, 6, 7, 8 points. And then I want to select these control polygon segments and make them vertical. And then over here, 1, 2, 3, make them horizontal. So that's the connection taken care of. You don't need to make this curvature continuous because it's collinear. And then I'm going to select the 6 control polygon segments and make them equal. Okay, now I'm going to bring up my reference, the lens, and I'll just drag this point here until we're pretty much roughly, there we go, lined up, and put a length dimension on that. Okay, so that's the top. Curvature, self-explanatory. Okay, just hide that reference. So now I just want to make this a closed sketch for the purposes of making this a planar surface. Vertical, horizontal, okay. Then we'll go insert surface, planar surface. Okay, and now we want to do the same thing but on the rear face. So rear face sketch, normal 2, turn it around, and again we need a degree 7 spline, so Bezier curve, 1, 2, 3, 4, 5, 6, 7, 8 points, and we'll get those horizontal, vertical, and then make the 6 segments the same length. It's a pain because you can't really see it. Okay, equal. Something's not right there, we're not consonant to that point. Okay, now we'll just bring up the case of the watch. It's the reference. And I'll just drag this point here until it's roughly the same. And throw a dimension on there. Close enough. Oh, whoops, I have to close that sketch. Right, we can go insert surface, planar. Okay, so I'll knit those together. Now it's time to try the blend out. Okay, let's try, we'll just dive in, boundary blend, boundary surface, sorry. Curves in one direction, I'm just going to turn off curvature combs. And then in the second direction, let's just see what we get. These 2 edges want to be curvature continuous. And then we'll probably need 100% curvature influence there. And these, let's see what happens if we go curvature to face. I'm guessing this is going to be a bit flat. Okay, let's turn zebra stripes on. Yeah, you can see a bit of weirdness going on there. Blushing a bit there. Okay, so the curvature is probably, just make this tangent for now. I want to compare this to the reference, the watch case. I'll bring that up. Okay, so our surface is way too flat through the middle. So, of course, this surface here was made in Rhino, manipulating CVs manually. So I don't have that luxury. So I'm going to have to add, in Solidworks, I'm going to have to add another curve. I can either add a curve in this direction or a curve in this direction, and in this case I think I'll add one in this direction. So just roll back before the boundary surface, and then on the top plane I'm going to add another sketch much like these other ones. So I need a style spline, Bezier. I'll add 8 points. 2, 3, 4, 5, 6, 7, 8. And make this side vertical. This side horizontal. I crossed over because I got a bit crazy there. Okay, and then make the 6. Control polygon. Segments. Equal. And bring up my reference, the watch shell. A normal, and I'll just drag this point down here until it's roughly correct. There's a cutout here where the band attaches, so well, it's probably a little bit different in there. Again, this is pretty much this isn't the setup I had in Rhino because I didn't need to put a curve through here. I manipulated the points manually to get the fullness of the surface. So Solidworks, I'm very much reliant on the curves. Okay, and now I will roll forward past that boundary surface and we'll stick the sketch we just made. Just this direction here. Then sketches on, add that sketch. I might have a quick look at curvature combs in this direction, a bit ropey, but nothing's changing there. Let's have a look. Change direction with the curvature combs. It's not too bad. There's no big peaks near the boundary as far as I can tell. Yeah, so you really have to have your tangent influence up higher because otherwise you get this little wiggle. Okay, now save that. Zebra stripes. Have a look at this. See if it's okay. It's much better with that, having that extra control curve through here, and not having a curvature continuous constraint on that boundary. Even though reading the zebra stripes, you can't see a kink there, so it looks like it's done what Solidworks normally does, and it's curvature continuous anyway, if your input geometry is suitable. And let's check the back. It doesn't look too bad. Yeah, so as I was saying, in Rhino, manually manipulate the CVs to get the fullness of that surface, and in Solidworks I have to add another control curve through there. Now of course, because I've done that, I can't control, I wanted this to be the widest point at the midpoint, I've got no control over that through the surface because it will just do what it does. So if you want to control that, you probably have to add a cross section through this way, and then problem with SolidWorks sometimes is your over-defined surfaces, too many curves, you start getting wrinkles. Okay, I'm just going to knit this together and we'll mirror it over. And then repeat that again, but with the front plane, bodies to mirror. And I'll knit that together. So one thing I should point out when you use knit, probably notice this function in there, this feature, which is merge entities. So merge entities, if you see our knit here, it's left this planar surface as 4 faces, this extrude is 2, these extrudes is 2. If you go merge entities, and the back's several faces as well, if you go merge entities, it will detect planar faces or extruded faces and merge them and get rid of those surface breaks, so it tidies things up. Okay. Doesn't look too bad. I mean, hard to tell without spending a while analysing it, and then also probably pay to put a cut through here and start looking at breaking out the lens. You might see then some, if this is tracking, the surface is tracking okay. I'll just try my, let's just make this solid, insert boss, thicken, create solid from close volume, because Solidworks sometimes only applies the higher under your options image quality. You ramp things up into higher. If it's a surface model, sometimes it doesn't actually apply that setting or keep that setting until you make it solid, which is a bit of a pain. So I'm just going to use my deviation analysis, draft analysis with my home-baked ISO line analysis. See what this looks like. Okay. So you can see the surface kind of undulates a bit through here, but that's because the section's getting deeper in this direction. So that's probably okay. So it looks like it's done a half decent job. So there we go. That's the main form. Apple Watch. This is a Series 3 compared to an old Rhino model of mine. Trying to recreate it in SolidWorks. So boundary blend with 2 sections in one direction and three sections in the second direction. Looks like it did a half decent job. I might follow up with this with another video and maybe flesh this out a bit more, maybe break out the lens and maybe break out something else that will sort of be a telltale for how good the form is by maybe the cuts for the band, because I think that will highlight the form if there's any weirdness going on. Yeah, cool. Andrew Jackson, AJ Design Studio. Friday night, fun with SolidWorks. Have a good weekend, everybody. See you later. And if you find this useful, please subscribe. Bye.